and my name is Rasmus Hellberg, and I'm working for Qualcomm in product management for private networks. And I'm going to talk about practical innovations for 5G in private networks. So I think we all know all the opportunities of 5G, the different use cases and so forth. It's a wide range of industries and use cases that has to be met. So there are different optimizations and different needs in all these different use cases. And it's not really that one single solution can fit everything here. So there needs to be some choice and multi-vendor to meet all these use cases, but still we have to make it possible to scale it up and package it in a way so you get the benefits of a private network can be used in multiple use cases, but still have the customization, optimizations, and differentiation that's needed for these use cases. So that's something I'm going to touch upon in this discussion. How do we do that? The other aspect is the spectrum aspect. We have to make use of all the spectrum that is possible, but not all spectrum will fit all situations. Spectrum is really the lifeblood here. Given just some use case examples like smarter warehouses, manufacturing is also one area that's very interesting initially to discuss the use cases. I think most people have seen all the use cases. We don't have to discuss that, but I think the appeal of 5G with the coverage, the reliability, and the security and so forth is going to be very important for these kind of use cases. This might not need the ultra reliable capabilities you will see that you need for manufacturing some cases, but still low latency is important for these use cases as well. So here I think sub-6 is going to be important to get the coverage you need in this type of environment. But you can also imagine to maybe not some warehouses, but more when you get the offices where you start to use millimeter wave to get extreme data rates and extreme capacity to support, for instance, I mean, we have an example of AI cameras here. If you feed that to some AI that's not exactly at the camera, that's one use case where you need a lot of data. But initially we have to start with sub-6, 3.5, 3.7, and so forth. I picked this use case too also because if you go back to the spectrum angle, it's not only going to be about sub-6 and millimeter wave. Millimeter wave, for instance, might not be the best option for wide coverage. It could be very good for a spot coverage, but here we can see that we need some sub-6 to get good, especially coverage among all these containers that are blocking the signal. So the spectrum aspect becomes important here as well for a lot of use cases that I'm sure you have seen many times before. So discussing the spectrum bands, I mean, we have to make use of all spectrum bands for public network as well as private networks. And there's an opportunity to expand to more types of spectrum solutions like shared spectrum and unlicensed spectrum. The main focus in the industry has always been licensed spectrum in the sense that it has exclusive use for the user. And for public networks, that's obvious. We also see that also coming up for private networks in many regions. Europe, Latin America, we see that in Japan and so forth. Latin America, I would say maybe more Brazil, not all the countries, but at least some countries in Latin America. In the US, we have also more maybe examples of the shared spectrum with CBRS. But licensed spectrum to exclusive use is always something that the industry is focusing on both for public and private. And we have great opportunities now with the availability of local spectrum for private network that can be used within the factory's premises and then by another factory, another location, and so forth. Unlicensed spectrum is also very attractive to get a lot of capacity and used for 5G. It will take a little bit longer time, but we're working on getting Wi-Fi 6 to be used, and that can complement well the private networks to get capacity today when you don't have the reliability, coverage, and maybe security needs that 5G demands, and also depends on how much licensed spectrum is available. Millimeter wave is also going to be exciting for unlicensed spectrum becoming available across the globe, and then not all countries maybe initially, but that also an opportunity then to really boost the capacity for some of these private networks. But initially, given the situation where spectrum is available for private networks, it's really going to be the 3.5 and up band, and 77, 78, 79, and so forth, around 4 gigahertz, depending on the region too. And that has excellent coverage capabilities for the typical applications, and especially indoor, and the reliability that's needed. But gradually, as spectrum becomes available, we would like to also, or we expect to see millimeter wave coming along to support more capacity. So spectrum is very important for the progress of private networks, but then also what are the obstacles that we have to overcome to make this successful at a scale? So we think that you need to make use of the power of 5G and get the full potential of 5G, and get the optimizations, the configurations, the use cases sort of set up and handled in a way so that even people that do not know anything about 5G can use this system easily. If you look at surveys, a lot of entities, enterprises that are interested in private networks, they won't have managed network, but we also believe that it has to be as simple as the end user can manage it. And that means that these use cases, advanced use cases, has to be set up in a way so you hide the 5G complexity. And then we saw there's a lot of different types of private networks. So there's not only one solution that can fit all use cases. That's pretty obvious. So we think that the industry needs some pre-integrated solution that you have multi-vendor choice. If one solution is outdoor, the other indoor, one is focused on warehousing. There could be certain combinations that are suitable for specific use cases and verticals. And the third point is simplify the deployment and management, to really simplify it, plug and play, and the management in a way, as I said before, that so that even the enterprise themselves can manage it, but you get still the full potential of these advanced use cases, and it takes care of the handover, the coverage, optimization, assure the services, you get the QS that are supposed to be met, and so forth. So how do we, from as Qualcomm, then look into this? We will do that in two ways. We will have a partner system, ecosystem partner program, where we bring partners together for the connectivity part of the 5G network, the core network, the small cell, and we also bring in an automation platform to enable the planning and the deployment and the operation of the network. Then we work with system integrators that have the vertical specific knowledge, the channel knowledge for whatever vertical that's needed, if it's warehouse and manufacturing, hospital, and if it's ports, and so forth. And they add then the specific use cases and customize it in a way that that specific customer needs, meets their customer's needs, and deploys and can also manage the network if that's what decided by the end customer. So that the end customer can get one-stop complete solution that looks like a vertical solution, but it's really with multi-vendor choice. So what we do to enable this is we validate in our lab the solution and we test the connectivity end to end. And we allow then choice of partners that the FSM, FSM is our small cell solution that is an ecosystem of our partners that are using FSM for small cells. So this is really to design to remove deployment roadblocks and also reduce the need for expertise in 5G, because it will be ready to go with automation and 5G profiles for the use cases, but still the customizations that are needed to meet the customer needs. And we want to enable a flow from planning to deployment operation that is seamless and repeatable. And so that if you create a template for one deployment, it could be reused for another effort. So you start with tools like estimate the total cost of ownership, which is something simple as just understanding what are the use cases you're going to use and what is cost. And then if the customer is fine, then it's time to go to more detailed planning, RF planning, and onboarding of the project, set up what profiles are going to be used, and then have a zero-touch provisioning deployment to install and automatically configure everything. We also think that's good. What we provide is an acceptance test where you have test devices that can be used to create traffic before the actual devices are there, to just verify that everything is fine before handing over. And then as gradually as use cases and devices are added, they are instantiated and automatically optimized, configured, depending on what the needs are. If they need to assure a certain QoS or certain policy, optimize the coverage and so forth. And then you go to the next step, operations, view, analyze, reconfigure, and that's supposed to be planned to be completely automatic. So you have to remove, go around again maybe and expand and add more devices, more sites and so forth. So maybe this is more like of a loop. So this is the summary of what we plan to do. To support the digital transformation of industries with private networks, we're working on two fronts. One is the ecosystem partner program with devices, small cells, core network. We work with system integrators, applications, use cases on top. Then we work with our automation platform that is sort of hiding all the complexity for plug and play deployment and automated operations. Depending on the connectivity needs for the enterprise use cases, we get the connectivity requirements, and then it automatically assures and optimizes this application. And the idea is also that you can provide additional information here from devices, for instance, device data that can be beneficial for external application. And we want to make it in a way so our partners can customize it and differentiate and program the solution, the cloud solution. So the partner program that we do is, horizontal cloud automation solution spanning planning, deployment, operations. And in the partner program, we validate the end-to-end private network solution connectivity to really enable multi-vendor choice and ecosystem enablement. And on top of that, we also bring in the device ecosystem and solutions. So this is a way we think is going to accelerate the deployment of private networks with multi-vendor choice and create a horizontal ecosystem that is ready to go for specific verticals and use cases and optimization that is needed to be customized for the specific verticals needs or enterprise need, but still allowing get the best breed of solutions with the multi-vendor choice, and make it simple for the system integrators to take the connectivity layer by pre-integrating, testing that in our labs. So I think I used my time. So thank you for your attention. Bye.
Hello, everybody. My name is TJ Forner. I'm a director of market development for private networks over at Commscope. I want to thank everybody for joining us here for this quick little session on private networks or private 5G networks and the cloud and how the two are tied together. Let's go ahead and get started. So starting off, let's look at the market for a perspective. We've been watching the market for private networks for a few years, and all the market analysts have really been coming back with the same kind of story of which industries they think are going to take the most benefit out of private cellular networks. And a lot of those reasons that they look at manufacturing and transportation and energy and utilities is because those are the industries that are really going through some digital transformation. They're looking at how they take their OT and their IT infrastructure, bring it together, and evolve it to bring to solve new business processes with new business applications. They're ever evolving. They've got to look at ways to include sustainability. They've got to look at ways to do predictive maintenance, predictive quality, and gain some factory efficiencies. And most importantly, too, is network security. As we all are at the cusp of listening to more and more breaches of network security, cellular technology brings an enhanced network security with it. So it's a favorable solution to look at when you're starting to do your digital transformation, add new technology into your facilities. And then the last thing too is a lot of these industries are looking to be built on the cloud. So part of that digital transformation is building their solutions on the cloud, leveraging the tools of the cloud, the ecosystem of the cloud, and all the capabilities that it has ahead of it. Now, when it comes to private networks, it's the early adopters we saw were looking at deploying their networks 100% on-prem. In this report back from one of the market analysts, I think really has shown its predictions quite well. In our early days at Commscope, helping customers with their first private networks, it was bring it all on-prem, let me play with it here before I do anything else with it. And then quickly over the last couple of years, we've watched those same customers and new entrants, new customers looking to use this innovative technology, coming in, looking at it from, I want a hybrid approach. I'm working on it with a cloud provider. I want to manage it all from the cloud, and I want to have multiple facilities that are out, spread across the landscape. And I need to be able to manage all those networks from one place, but yet have the control of data in all of those network locations. So this is where the cloud really started to bring some favorability in, is they were able to start to say, I've got a cloud that's regionally based or globally based, and we can then bring it out as far as you need, and we can bring it to where you need these private networks to deliver value. And that goes right into what are the many benefits of the cloud. So the multiple different cloud providers all out there provide a global footprint. Build it once in a cloud environment and be able to bring it, your application or your service, and be able to bring it anywhere you want. And then be able to bring it regionally too. Regionalize it, bring it closer to the end location. So build it in one spot, bring it closer to the end app or the end location. And then with those regional zones, they also offer the ability to be highly available, architecturally designed and configured so that if one data center goes down in the cloud, there's another data center right there as a redundant backup. So you want that high availability. So you can see the benefits of the cloud are from a global reach to a regional reach down to, even in your local region, you can now have a highly available solution, running your network. And then the cloud started to bring over the last several years, edge compute to the solution. And the edge compute that they brought to the solution was something that looked identical to the cloud. So if you built it on the cloud, you could then push it down to your edge, appliance, and that edge appliance looked just like the cloud. So they wanted to make it easy. And then the key term out of all of it at the end of the day, and why the cloud has become so valuable, is because the cloud has virtualized everything. That's where the value of the cloud really comes in, is not only from its global reach, but virtualizing all of the functions, all of the key aspects. Now that's where we tie in very nicely to private networks. Private networks used to be built on, not private networks, telecom networks used to be built on proprietary hardware. Proprietary hardware that was expensive, large, cumbersome. You needed special skills to be able to operate it and be able to manage it. But over the last several years, the telecom functions, even the telecom operators, have realized that they needed to evolve their technology. And their technology has gone from this proprietary solution running on proprietary hardware now to becoming network functions, our virtual machines that have been created as a virtual network function that now can run on the cloud. The most important one to start off with when it comes to private networks is the 5G core or the 4G core, but 5G is a much better marketing term nowadays. But the 5G core is the brains behind a telecom network. This is where you set all your policies. This is where you tell the devices where they can send data. So they needed to virtualize this core. This core used to be, like I said, running on proprietary hardware. Now it's evolved to a point where it can be virtualized and it can run on any cloud. And that where that 5G core now sits, you also sit with your business applications. All of these things are starting to show up in the same location. And then continuing to build that story of what a private network needs. First, you need that 5G core. Second thing you need is that radio access network. The radio access network too used to be built on proprietary hardware that you'd have to order, ship to the site. It would only work with the 5G core, or it's been thoroughly tested in the background. And you can see in this scenario right here, I'm showing that hybrid model that we talked about a few slides back, where now you can put your core in the cloud, you can put your 5G RAN functions, your radio functions on the edge, and then you can connect those radio functions out to the actual radio that operates and manages the radio. But one of the key things that has been the catalyst for all of this was spectrum, making spectrum available to the end customer like you and I. Spectrum is $1 billion industry that all the major incumbents, mobile network operators have spent billions of dollars acquiring so that they can operate and manage mobile cellular networks. For the first time a couple of years ago, we started to see that availability of spectrum for cellular technology available to the consumer. In North America, it was the CBRS spectrum, where we are able to finally have our own spectrum that we could then go buy these network functions and run them on the edge, run them in the cloud. We could buy the same radios that the mobile network operators were acquiring as well. And now we can stand up our own small scale private cellular network with all the compute capability we need thanks to the cloud, all the network functions that we need thanks to all the OEMs that have created these network functions. And then we could stitch them all together very nicely. And what is brought up about that is it all started at 4G. 4G was the first time that these network functions were starting to become available to the average consumer and being able to launch them on the cloud. And why it's so important for us is because now by deploying them on the cloud, it reduces your time to market. So whether you're developing a solution for a customer or you're the end customer and you want to launch this network, you no longer have to wait for long and costly procurement cycles. You can quickly get a network function like a 4G core or 5G core. You can deploy it and you can get it up and running quickly. And then by putting these network functions on the same cloud that everybody else is running business applications on, that's filled with the developer ecosystem, we now have the opportunity to create microservices like we've never seen before on a cellular technology network. These microservices will be things that we would have never thought about doing. Maybe it's going to be policy, standardized policy. Maybe it's going to be different qualities of service. Maybe it's going to be asset tracking the location, just new microservices that you can now add on top of this, cloud-based 4G, 5G network that, brings continued value to your business or the business that you're operating the network for somebody else. And when it comes to operational efficiencies, it kind of goes back to that too. By being able to start small and think like cloud and build like cloud, is you only have to deploy the 5G core or 4G core that makes sense from the size perspective. If you only have 10 devices that are going to connect to it because you're still developing your strategy, you don't have to go spend hundreds of thousands of dollars for a fully operational core or millions of dollars for a commercial grade operational core. You can start small, and with it being built in the cloud, you can scale up. And then therefore, hopefully start helping drive out the cost as well by sharing cloud resources. If you have an edge appliance on an edge appliance from a cloud and you have it on your premise, that edge appliance could be running business applications as well as your 4G, 5G private network. So it's about sharing infrastructure, it's about sharing cloud resources, and about keeping them all stitched together and close. Because it's going to come down to what's the killer app, right? And I like this slide. I built this one a while back, but it's we all want that killer app to be artificially intelligent focused applications or AR, VR applications, because that's where it's really cool to think about, having your own private network, and, an AI is going to be there, or VR is going to be there. And that's true. I think we'll definitely see these things come. We've been working with some customers that have very, very exciting and creative ideas of how they want to evolve their business. But most importantly, it's going to be the developer ecosystem now that has access to this technology. And what I mean by access to it is the developer ecosystem who's been building their applications and leveraging the tools of the cloud, of the different cloud players, now has a different way to use their applications. With cellular technology, they know they're going to get lower latency. They know they're going to get better mobility. They know they're going to get more reliability, more security, all the key pillars of a cellular technology. So as an app developer and as a business owner, you can look to the app developers and say, I need your app to do this, and I'm going to run it across my cellular network that's running on the same platform that you're developing your applications. Let's work together and make this, let's create some great business outcomes of how we can leverage this. And that goes back into, video inspection, robotics, autonomous vehicles. We're seeing all of these play out now. And one of the greatest ones that we've seen over the last 2 years has been video analytics, really. It's where we've seen them take just a single video stream and be able to make business decisions on it, whether it's face mask detection in the time of COVID, worker safety where somebody crosses a line and they shouldn't go across that line. But it's in knowing that you have a quality feed, and then that quality feed is giving quality data back up to the cloud. Now, all the industries that we've been working with at Commscope over the last 2.5, 3 years have all been trying different proof of concepts. And we're in a world of proof of concept purgatory some days, it seems like. But it's been exciting to see the creative thinking and the creative minds of what industry is going to do what with private cellular networks and the cloud connected together. And what we've seen is the success has really been if they do have a cloud strategy already. That means they're already toying with some really great applications in the cloud. And then they tie on together this private network that's running in that same cloud, and they start to see the operational efficiency from their point of view. Now, video analytics and video has been the key one for us in the past. We've started to definitely see some autonomous vehicles too, that nice handover from cell boundary to cell boundary without disruption. So it's been exciting to watch private networks use that. And I think that's going to be great in warehousing and logistics and distribution facilities. But what is really holding us back still to this day is the end device ecosystem, because we have all of the other key tools that we need available. We have the cloud, we've got network functions, we've got radios that are operating across the correct spectrums for these private networks. But at the end, it comes down to cost-effective end devices. And now these end devices are what are going to be the key thing that either help propel private networks to success, or they're the things that are going to keep it stunted down. So yes, we can connect tablets and PCs, but it's going to be that low cost where you want to just be able to put up hundreds and hundreds of different sensors to get different data into the cloud so that you can bring value to that data, bring value to your business. That's really going to drive the success of private networks. So looking forward to that, working forward to continuing to evolve, but I think all the right parts are in place to get the ecosystem going, to get the industry going. And with that, I want to thank you guys for your time and spending with us here, talking a little bit about private networks and how the private networks and the cloud together are going to bring the greatest success for this industry. Thank you.
Hi everyone, greetings. This is Ravisana from Reliance Geo, and warm greetings from Small Cell Forum. This is SEWS US chapter, and in this specific discussion, I'm going to update you about our achievements and progress related to our new initiative, brand new initiative, and talk of the town. 5G private enterprise solutions isolated. There are two flavors over here, and today we are going to talk about the one. First of all, like I personally work heavily with Small Cell Forum, being a part of Reliance Geo product development group, and so proud to support it for some time, and feeling happy to contribute towards the 5G enterprise solutions. I'm leading the solution group, and let's talk a bit on how exactly we progressed overall, and what will be our approach, and what we have achieved. So under the umbrella of Emerging Technology Group, there are the two chairs for this initiative, me as well as Prabhakar Chidrapu. Today I'll be presenting it. Prabhakar, I always appreciate his support to be the one who always kind of supervise a lot of things for us. So as I said, so this is Emerging Technology Group private network blueprints, headed by Ravi Sinha, me, myself, Chair ETGGO, as well as Prabhakar Chidrapu, the Chair of SCF. So 5G Enterprise private new blueprints, network blueprints initiative. Basically, there are 4 components, as you can see from bottom to top. Components which is come under FAPI. So there are 2 different types, right? FAPI for stack integration, as well as NFAPI, where a stack MAC and PHY can be integrated over the network. And recently, we are developing a new brand around our Split 6, and there'll be multiple products coming out of it. And then on the top of it, you have deployers like the hosted Open RAN private network blueprints, which falls under that. And then you have a marketplace where the standard kind of demand forecast analysis, as well as a standard marketplace can be explored. This is how it is organized. So as you can see on the third bullet, while based on the standard specifications, the blueprints will be specific to certain rollout scenarios that are not currently addressed by the frameworks of other organizations. Basically, since this initiative is very much focused towards the small cells, and all what we are doing is making sure that this particular blueprints and frameworks are uniquely stretched around small cells. So let me go to the next page here. So as you can see that the blueprints is a multiple communities are common, you can say, solutions here. So one second, let me minimize it so that you can also see. So it's a multiple communities, common goals. So SCF has published its FAPI network FAPI specs, FAPI and FAPI specs in June 2021. And we are keep on producing the new versions of it, and around Split 6. The stepping stone to not only 5G service-based network design and product packaging, but also to cloud-native infrastructure, because 5G is all moving around cloud-native infra, which has got automation capabilities as well as the resource poolings and a lot of other benefits. And native security can also be stitched around. So it's a good segue for the next set of technologies coming. SCF has initiated baseline research and strategy frameworks to develop private cellular network blueprints and system test frameworks in partnership with the small cell industry, MNOs and OEMs. And that's the reason why the right-hand side, you can see that our contributors are coming from the MNO, OEMs, test solution vendors, system integrators, automation vendors, infrastructure vendors, and component vendors. And each of them has got a specific role to play to bring the whole ecosystem, a fabric, or you can say a framework, and individual thread to that as a blueprint. So I'll go to the next page of it. So 5G private network blueprints, if you can see over here, 5G small cell fabric is the baseline. It is the infrastructure as a service, and up to some extent platform as a service. But on the top of it, you can see that the cloud native is the one who is also bringing a lot of automations and magic around. And of course, the next generation services, starting from Industry 4.0, automotive, agri-tech, and auto self-drive cars, and many more to come. So this is how it will move, and we are also in talk with multiple other automotive companies to combine your roadside units along with our cloud native infra, as well as the small cell fabric with all the assets we have in terms of components. So here, the constituents of the blueprints are components, modules, and end-to-end. So you can see the products. So multiple viable offerings. So the minimum viable offerings, as you can see, is nothing but a minimum viable product catalogs, where based on the different threads you will have the requirements, feature, functionalities, architecture, the guidelines, everything wrapped up in a package called MVO. So MVO is the main, you can say the mothership, but then it will be supported by sub-documents, which are nothing but the product requirement documents or MVP, coming from infrastructure as a service, product as a service, and cloud assets as a service, network connectivity as a service, system integration and test as a service, so multiple layers, which we will see later on. And then you have module, which is nothing but a reference design. So in past also, we have worked on multiple reference designs, starting from, you can say, starting from small cell reference design. There also, like part 1 is done, part 2 we're working on, and then multiple others are in the pipelines. So end-to-end use cases and services, individual blueprints, what we're working on, where like if you take one thread, it will be one blueprint. If you take another blueprint, like thread, another blueprint. So just take an example. If we are taking a thread of isolated, where like it is just a single piece of network, not connected with the hyper scalers or not connected with the MNO, then this is one thread. Another one in coordination with MNO, that is another blueprints, and there also multiple layers has got their own fabric of blueprints coming around. So this is the private network have high potential with small cells, and blueprints could help unlock that. So you can see starting from 2019 to 2026, the growth of radio units. As you can see, like 2026 is going up to 3,000K of the units, and it will be even more. However, there are barriers. 36% of the deployers say they would roll out more quickly if more plug and play deployments were enabled. And enterprise are accustomed to certifications and other networks, and will demand the same for cellular. So comparing selected industry blueprints initiative focused on cellular and or private networks. So on the left hand side, you can see that some of the initiative by the great STOs we have, starting from KIP to OAISA to 5GA, and then Uni 5G blueprints. They all have a lot of benefits. The industry can get the benefit out of these initiatives, but of course, like most of them are focused towards the micro kind of environments, and very much focused to a specific kind of services. Here we are with SCF initiative of blueprints. We're looking mainly into the small cell fabric and all the assets of ours, including FAPI and FAPI, and many more, which we are working on. So that's how like it is a little different. As you can see over here, we do have our SRUs getting connected on a cloud asset PU and CU. And then you are getting connected with the hyperscalers. In case hyperscaler can play individually with individual public network operators or private network operators, I'm sorry, as well as they can go without them too. So based on the kind of network you're looking for, the private network operator can collaborate with hyperscalers as well as PNOs, MNOs. MNO will be going to be a big one. So we wanted to establish the blueprints first, isolated, and then later on go for a full-fledged MNO coordinated network. So here, as you can see that starting from business use cases to the telco use cases to the automation use cases to the simple to the system integration use cases, you have the public clouds and you have private networks. So how exactly they're aligned, starting from enterprise cloud edge and infra, then 5G RAN, core network, smart IoT, IP routing and transport. From the telco use case side, on-prem orchestration, going for the SMO side of it, or on-premise system integration and test, which is a part of your SINT as a service. Similarly, like if you are collaborating with the hyperscalers, definitely you have your public system integrations, which hyperscaler can provide, then SMO, which hyperscaler can bring, then CDC, IT services, billing, ERP, versus BSS, and all those things can come from them based on the kind of business and collaborations you have. And business use cases, definitely anything B2B, B2B2B, hyperscalers can play a big role over here. So I will quickly go to the system framework with example stakeholders. So infrastructure as a service, mainly unlicensed approach versus licensed approach. You can see that SRU, G-Node V, DU, G-Node V appliance vendors, they are the ones who are going to play a big role there. Hardware infrastructure vendors and CAS vendors, all those things are connectivity as a service and all. Whereas the licensed vendors, the same thing, except that some of the things may be specific to a licensed vendor, like container as a service, RTOS, Docker runtime, Kubernetes management. Those things, if it is a license, then definitely it will be done with the highly customized ones. If it is for unlicensed approach, open source, then definitely you can pick up whatever you get from the open source industry. CNI, CSI, CRI, the fabric of that, and open source versus a structured, someone like Red Hat or someone like VMware or Windover. So those kind of selections, like being SCF, we are more focused to open source initiatives. So definitely we are collaborating with multiples who can provide the requirements as well as specifications and some of the like source codes too. Network function services, of course, RAN and port sites, as you can see. Over here also, there are some open source as well as like some of the customized ones coming from multiple vendors of ours and outside. So we'll be focusing mainly towards the members who are contributing to ours and some of their recommendations you can follow to bring your own networks. Network SMO vendors, both sides, and system integrations, both sides. So this is how the whole fabric is built. As you can see, SCF Cloud Native Framework for 5G, network functions and services. You have your infrastructure service hardware, operating systems, container runtime, VM runtime, the Kubernetes, CNI, CSI, CRI, SDN and all for PaaS, then multi-cloud supports and orchestration on the top, and then workloads, you have RAN, core, AIML services. And then on the top, you have marketplace, assurance, charging and billing, all those things under 5G Cloud Native Stack Fabric. So this is how they look. So this was one of the glimpses of what we are working on. So enterprise blueprints, where we are. So our target is close to 19 weeks. We have already worked like that. Now it will be probably 19, 20, 21 weeks. We have achieved a lot. We have all the baseline documents in place. We are putting content so that it will be of great use for the industry. We have created 10 baseline docs and including one minimum viable offerings, plus close to 9 of the PRDs or MVPs, individual to infrastructure service, platform as a service, multiple more components we are putting in. 40% work is completed, and the team is also working to collaboration with industry, academia, and some of the forward-thinking open interfaces and source forums to move this blueprint initiative to the next stage. Our delivery roadmap, we are expecting Q3 2022 for this one. And of course, Q2 2020, Q3 2022 is our isolated phase 1 case. And then Q2 2023 for MNO coordinated blueprint cases. So this is how we are working and marching towards a fruitful outcome for 5G enterprise blueprints. So this is what we had. I'll stop share. And I would like to thank the the listeners and people who are going to watch the video for this virtual plenary. And if there is any question, you can always write to CBRS. And thank you very much. Once again, this is Ravi Sinha. Thanks a lot. Take care.
Hello, everyone. My name is Adil Kidwai. I'm the head of products at HQ. Before I start into the presentation, let me walk you through our journey at HQ a little bit. 4 years ago, when we started our journey at HQ, we wanted to play in the field of wireless infrastructure. Very soon, we were confronted with a question. Well, there are different types of wireless infrastructure components and requirements. For example, in the small cell, there could be enterprise wireless infrastructure scenarios where latency matters, high throughput is required. There could be outdoor scenarios. There could be indoor scenarios as well for a small cell. Now, adding to that complexity, if you think about macro environment, where there could be a cell site, macro carriers, and there could be pre-aggregation node scenarios where a bunch of cell sites come and aggregate. We were confronted with a question, what is the optimal architecture which can cater all of these multiple types of requirements? Adding to that, there's another level of complexity, and that complexity is brought up by the Open RAN features. There could be different types of splits available. There could be 7.2 split, or 7.3, or option 6, or option 2, or option 0. These different splits are useful for different types of scenarios. For example, if you are very, very latency sensitive, you may want to run the entire G-Node B not only into one box, but also in a single chip. You may also want to run part of UPF from the core network into the same chip as well. So there you will go with option 2 or option 0. If there is a macro deployment, you may want to go with option 7.2 or option 7.3. So now if you add all the options that are available on the top of the slide to the options that are available at the bottom of the slide, then there are very, very different scenarios that are possible and required. Adding to that, 5G has its own challenges because of the transition from 4G to 5G. Now, the question is, can the same silicon support 4G and 5G simultaneously, or should it support it simultaneously? LTE is here now, 5G is upcoming. LTE is not going anywhere for next 3-4 years, which means that one has to think what happens when you transition from 4G to 5G, right? Do you kind of throw away the box? Do you buy new chips? What do you do, right? Because there is millions and millions of dollars investment in wireless infrastructure. 4G to 5G transition problem becomes very, very significant. Okay, so this is kind of the problem space that we were confronted with when we started our journey, and we found an optimal architecture which would address all these problems. So let me move forward to discuss that architecture with you. What we came up with was a solution which is RISC-V based, a silicon which is RISC-V based, where we run layer 1. And on top of that, we decided to provide the entire physical layer in a deployable format. Keep in mind, there's a difference between a reference physical layer stack and a deployable physical layer stack. We provide a deployable physical layer stack. All 4G and 5G algorithms are provided into deployable form. On top of that, we are FAPI compliant, and by virtue of that, we can connect to any third-party layer 2, layer 3 without any issues, right? We are fully FAPI compliant. Now, this silicon that we have and the layer 1 is programmable, meaning we can cut into the any ORN split. We can turn on and turn off the blocks and control the power consumption depending upon the user throughput. So all the requirements that I mentioned in the previous slide could be made possible by this architecture. This architecture also serves small cells which is the focus of this conversation, we also are a competitor and a leader in the space of ORAN, macro ORAN PCI card. So all in all, we offer a 4G plus 5G software-defined radio and provide unprecedented capacity in this silicon and in this PCI card at a fraction of power and cost. Now let me walk you through the details about the silicon a little bit. So on the left side, you'd see a cartoon diagram of the silicon where you see a bunch of processing blocks, if you may. The two major processing blocks are the following. The first is the signal processing complex. This is where the layer 1 runs on RISC-V processors. We have added a bunch of custom instructions to RISC-V processor to have 5G and 4G signal processing functions implemented. Adding to that is a FEC acceleration block, which has all the encoders and decoders like LDPC, polars, which are what all you need for 4G and 5G processing. The other subsystem in this chip is a CPU subsystem, where we have a multi-core, multi-thread ARM Neoverse subsystem on which layer 2 and layer 3 runs. On top of that, we have a protocol accelerator block, which has layer 2 and layer 3 accelerators for MAC and crypto processing. Keep in mind, as we move from a cloud-centric world to an edge-centric world, it is very important to process the information and the data at the edge itself, which means the solution that you provide has to be edge compatible, which means there has to be compute and there has to be connectivity. One cannot say that my solution has only compute and not connectivity, or vice versa. Compute and connectivity in our mind go together in the world that we are living in. In addition to this, we have a boot subsystem, an RF interface subsystem, and a very hefty I/O subsystem, because once you support split 7.2 and split 7.3, the front haul bandwidth becomes very demanding, which means the system requires very high front haul throughput. In addition to that, we have a bunch of Ethernet ports and PCI links as well. All in all, this silicon is massively parallel, is fully programmable, because we can add custom instructions to it in the RISC-V unit. And it integrates 4G, 5G, artificial intelligence, network processing, and CPU in one single compact silicon. And it runs with an open source GNU toolchain. Now, what do we offer as a company? Another problem statement actually that we saw was there is a bunch of parts that needed to be aggregated, meaning RF, a layer 1 PHY, a CPU, a NPU, and the respective software stacks. And we wanted to make this process very, very simple for our ODM and OEM partners. So we decided that we are going to take care of the RF and baseband interface as well, and provide a fully compliant, seamless integrated RF pre-tested in HQ lab to our customers. What I'm showing here is kind of a logical diagram of a small cell, right? At a component level. We as HQ offer everything in this blue box, right? Hardware and software. So we partner with a couple of RFIC vendors who provide us the RFIC chips, and we take care of the integration with the baseband, including the RF drivers, the predistortion, digital predistortion, and all the other RF calibrations, right? So what our OEM and ODM partners need to do is put together an RF front end as per the requirement of the use case. There could be use case where RF front end is, for example, the antennas could be transmitting 24 dBm EIRP. There could be other use cases where the antennas have to transmit higher EIRP. So our ODM and OEM partners put an RF front end. And in addition to that, all the other necessary components like PMIC, DDR memory, Ethernet PHYs, and etc. All in all, we make this process very simple. We provide you the entire gut of the small cell as one pre-integrated solution, interoperable with multiple devices already. Now, remember at the beginning of this talk, I was saying that the world that we live in is a world which requires connectivity and compute. a solution is no good if it is only compute or if it's only connectivity, because guess what? The data has to be processed where it is generated, at the edge. On the ARM Neoverse subsystem that we have in our silicon, we provide a bunch of compute capabilities in the platform. For example, you could run your GPU host driver here, which is very important for GPU rendering and low latency rendering. We also provide virtual machines and containers where you could run any third-party applications, right? Last but not the least, for low latency AR/VR applications, one must run the UPF and a part of core network in the RAM itself. This is where we kind of provide a capability to run a condensed core network onto this ARM Neoverse CPU subsystem, right? Keep in mind that this is a server-grade ARM CPU, the newest in the block, and this packs kind of a lot of punch together to run all these third-party applications. In addition to that, there is signal processing and AI complex, which is running on RISC-V, which is used to provide 5G connectivity, 4G connectivity, and machine learning and other applications. So all in all, in the silicon, what you got is a polymorphic connectivity plus compute running on ARM CPUs and the RISC-V CPUs. Now, remember at the beginning of the talk, I talked about what happens when you reform a network from 4G to 5G. All the carriers right now have 4G network, and they want to move to 5G. What happens when you move to 5G? Do you just throw away the box that you had for 4G? Do you buy new silicon? Keep in mind, it's a lot of capital investment that carriers have done on 4G. In this example, I'm showing HQ silicon connected with two RFICs. One RFIC is, for example, band N78 is a 4x4 RFIC. And the other RFIC is, let's call it LT band X. Okay, it's a real customer use case. I didn't want to disclose which exact band it is, but let's call it LT band X. And let's say the customer, meaning the carrier in this case, decides to reform LTE to 5G for the same bandwidth. So in this case, the same box has seamlessly transitioned and upgraded just using the software to be a 5G dual band G-Node B box, where this RFIC has been reprogrammed to work as a 5G RFIC. The entire baseband has been reprogrammed to be used as a 5G physical layer running on RISC-V and 5G L2 and L3 running on ARM Neoverse, whereas on the left side, this chip was running 5G and 4G PHY in addition to 5G layer 2, layer 3 and LT layer 2, layer 3. Okay, so the bottom line is the same HQ SoC runs both 4G and 5G PHY, and a seamless transition from 4G to 5G can happen only with HQ, and this is an over-the-air upgrade. You don't have to do anything with the box. So by doing all that, we make femtocells, enterprise indoor, outdoor, and outdoor macro cells possible. And all these boxes are made possible at a fraction of cost of what they're available today. We are a firm believer that eventually for 5G to become ubiquitous and have a place in every household and every factory, it has to come very, very close to the cost point of an enterprise Wi-Fi. And that is exactly what we achieve. With HQ solution, all these different types of scenarios and the solutions for a small cell are available at a fraction of cost and power. At the bottom of the slide, you will see some example specs of all these different types of solutions. In the end, I would like to introduce the team which made all this possible. Vinay is the CEO of the company and the founder. This is me. I'm the head of products. And this is my colleague Sriram, who is also sitting in the audience. We have grown to around 200 more and more people in the company. We are headquartered in Santa Clara, and we have design centers in San Diego, US, and in Bangalore, India. We have worked on a lot of marquee products in this field for a lot of marquee companies, including some of the names that are mentioned here. In addition to our immediate family, which has 200 people, we are also blessed to have a lot of luminary advisors. Paul and Matt, both are very senior executives at Qualcomm before they are on our advisory board, and we benefit greatly from their counsel on a day-to-day basis. Ajit is the FCC chairman, responsible for opening up the C-band in the US, and which the rest of the world followed. So with this, I hope I have done justice to all the smart men and women at HQ who had made this solution possible. And I hope the audience here is able to appreciate a level of integration that we are bringing to the table by bringing connectivity and compute together in the same silicon at very, very low cost and power. Thank you very much.
Hello, my name is Alan Ewing. I'm the Executive Director of Ongo Alliance, here to moderate a panel about private 5G networks and using CBRS as well as other shared spectrum and spectrum in general. So with us today, we have a really exciting panel of experts to discuss this topic. And what I'd like to do is go around the list of kind of my virtual room and introduce each of them and ask them to say a few words. So TJ, tell us a little bit about yourself.
All right, so thank you, Alan. TJ Forner, I'm with Commscope. I'm the Director of Product Market Development over at Commscope, focused on private networks. And this will be an exciting panel and topic to discuss today with everybody.
Thanks, TJ. Vikas, over to you.
Thanks, Alan. My name is Vikas Dixit, and I work with Reliance Geo as an Assistant Vice President, mainly in the new product division. I have around 22 years of telecom experience, mainly in the development of 3G, 4G, and 5G, and also contributing in the small cell forum in the different work items, and as well as leading one of the work items. Good to be part of the panel here. Thanks.
No, thank you. Rasmus.
Hey, Rasmus Hellberg is my name. I'm from Qualcomm in product management for private networks. So probably know Qualcomm from chipsets for devices and also for infrastructure, but I'm also looking into software-based solution for automation and management of private networks.
Very good, thank you. Adil.
Hi guys, thanks for having me here first of all. Happy to join this panel. I'm Adil. I'm the head of products at a startup called HQ. At HQ, we provide a programmable silicon and deployable physical layer for wireless infrastructure needs, all the way from small cells, femtocells, all the way to macro cells as a layer 1 acceleration card. Happy to be here.
Welcome. And Sasan.
Yeah, hi, my name is Sasan Ahmadi. I work for Mavenir, and I am the Vice President of Technology and Strategy in Mavenir. As you know, Mavenir actually is championing this, cloud native, solutions, and NPN or non-private, non-public networks or 5G private networks are actually one of the areas that, we are very interested and working with, many partners in the industry to deploy intelligent IoT, solutions, and besides other obviously micro networks that we are working with operators. Yeah, very happy to be in this panel.
Thanks, Hassan. Appreciate it. And thanks to all the panelists here. It's going to be, I think, an interesting conversation that we'll be able to share. So starting right off the bat, the discussion is all around 5G, private networks, et cetera. TJ, maybe I can pick on you to lead us off here as the leadoff hitter, so to speak, in the panel. When we talk about these types of private networks, private LTE rolls off the tongue, and LTE has been the standard which we've all enjoyed and used and continue to use. But really, why the step to 5G? What is the evolution here? Why is the drive in private networks in particular towards 5G?
Oh, great question to get kicked off. I think I'll start with this. It's been fascinating to put 4G in the hands of the enterprise customer for the first time. I think that's where it's built its excitement, and everybody's gotten excited when they hear 5G as well. But for the first time, not from an MNO's perspective, but we've been able to take technology now that spectrum has become available, especially with CBRS in the United States, and give the customers, the end users, the enterprises, the cores, the RAN, the management of their own SIMs, and allow them to play with this technology. And that, I think, has inspired them to get excited about what 5G could bring with even greater reliability, even more connected devices at the end of the day, and to be able to feel like they have truly a secure network on something that they've already been working on building themselves with their own digital transformation. 5G is really going to build on hyperscalers infrastructure and enterprise IT infrastructure. And that's exactly what 5G is going to bring to the customers. They're already working on their own digital transformation, and now 5G is part of that story for them. So I think to kind of get things kicked off, I think that's what excites everybody, is that they finally have a technology, a wireless technology, that is going to act and operate on the same type of digital transformation path that they're heading.
Thanks. Yeah, thanks for that, TJ. Sasan, any thoughts to add on to that?
Yeah, I think actually, 5G brings, obviously more capabilities and features, right? So depending on the use cases, yes, there are use cases that, LTE actually based private networks, may work. Like, for example, some surveillance, like, video surveillance, like, intelligent inventory, like, housekeeping, etc. But, there are use cases where obviously 5G, because of the enhanced URLLC capabilities, TSN capabilities, and etc., actually would add values that obviously encourage the vendors as well as the operators and enterprises, etc., actually to consider 5G over LTE.
Interesting. Rasmus, anything on your mind when it comes to the more of the chipset view, but also the Qualcomm view, perhaps, into 5G?
Yeah, I think we discussed use cases and the opportunity, but I think another factor is the opportunity to have something that's future-proof, that's a newest technology, that where you get new capabilities with. And with those capabilities, it goes also related to spectrum, for instance. I mean, a lot of the focus here maybe is for lower bands, CBRS and 3.5, and good propagation and reliability and so forth. But one opportunity with 5G and private networks that's coming is millimeter wave, extreme throughput, extreme capacity to new types of use cases in private network settings too. And if you look at the spectrum situation in the world, there's a lot of focus to get sub-6 going for industrial automation, manufacturing, and so forth, but also freeing up millimeter wave spectrum. So both of these, I would say that's also another opportunity with 5G to get access to even new types of spectrum.
Good, thanks, Richard. How about Vikas? Anything on, from your perspective?
Yeah, I think let's, as the other delegate says, that the 4G is just a starting point where we can see that the technology can be used in the private network field. But 5G is like built on top of that. It's added up many other things. So we already have seen the advantages in 4G, but in 5G, with the more and more use cases is coming up, especially for the indoors. I think the private network is going to be playing a very major role in 5G.
Adil, one of the things that kind of caught my ear as folks were discussing this is the thoughts about the verticals, the use cases, and kind of switching that to the verticals thinking. Where is 5G really going to shine as an option for private networks versus LTE, in your perspective?
Yeah, so 5G fundamentally offers few different features as compared to LTE. First of all, it's higher capacity, as we have all known. There's higher bandwidth available. Security is better in 5G. There are better provisions of security. There is there are URLC use cases, so better latency, and 5G is a little bit more efficient spectrally as compared to LTE, right? Roughly 15 to 18% more spectrally efficient as compared to LTE, right? So take all of this together, this brings a plethora of new use cases which can be realized with 5G, which could not be realized with LTE before, right? Factory automation use cases, digital twinning, fixed wireless with a fat data pipe, or some of the examples. But here, one of the things that I would like to emphasize is that as we talk about 5G, 4G is not going anywhere. 4G is here today. It will be there for next 3-4 years. The key question that I am asked from my customers is, what do I do when we transition from 4G to 5G, right? Will that be a seamless transition, a software upgrade, or do I have to rip and replace the box? So silicon vendors like us need to make sure that the investment that the operators are making in 4G, because they have 4G spectrum today, is not thrown away when we move to 5G. So right now we see a bunch of operators asking us to just deploy 5G, and a bunch of operators which are saying, well, I have 4G spectrum and 5G spectrum. I will deploy both NSA mode, 4G and 5G, but maybe in a year I will reform my 4G to 5G. Please make sure that I don't have to throw away the box. Please make sure that my millions of dollars that I'm investing is not thrown away. I think we as silicon providers need to make sure that that is addressed as well in our solutions.
Yeah, understood. Sasan, how about, from your perspective on the, the kinds of verticals here where this is really going to shine? Are there ones that are on top of mind from your perspective?
No, I cannot actually think of any vertical that 5G actually, would not be able, to address. As you know, in 3GPP it was decided that, the NR path would not actually address the machine type communication, right? And narrowband IoT or based on the LTE path actually, would address, all the applications for machine type communication. And that actually is, obviously a continuation of the LTE path that given, the importance of IoT and, applications and now industrial IoT applications, that actually would keep LTE, obviously alive and continuing actually for the foreseeable future. But as the other panelists actually mentioned, 5G has, better spectrum efficiency, better, capacity, access to wider spectrum choice, and so forth. Actually, so from that perspective, I cannot foresee any shortcoming actually that would necessitate the use of LTE. But also, the only thing that comes to my mind is the narrowband IoT based on LTE that is a very fundamental to IoT applications.
Thanks, Hasan. TJ, I mean, what do you say to someone who comes and says, well, LTE is good enough, but it's obvious that there is some advantages to a 5G private network. What's the distinction there?
Yeah, absolutely. I'm going to tag on to a little bit about what Sasan said too. It comes to, especially with IoT devices, it's going to come to capacity. I think that's going to be a really big one. And if you look at some of the industries that, the market analysts are, touting as going to be the big winners with 5G, like, manufacturing and logistics and warehousing, it really comes down to how many connected devices do you need today, and what's your business plan for how many connected devices are you seeing in the future? Just coming off of the Hanover Messe show over in Germany this last week and listening to the manufacturers talk about what 5G is going to do in that industry. And it does come down to, we need to just get as much data into the cloud or into some kind of service so that we can start to bring more value on top of it. So I think when I talk to different customers of making that transition from 4G to 5G, it's like, get your 4G network stood up today and start to play with it. You're going to have, end devices are still one of the biggest things that are holding us back from really growing quickly with private networks. But as the end devices start to become more available, you're going to start to find more and more value out of that wireless network. So the 4G is going to get you what you need to get done today, and the 5G is going to give you a lot of the key things that the other gentlemen on the panel were talking about: greater security, greater reliability, but it's going to allow you to connect, millions of devices so that you can get more and more value out of what you're doing inside your facility. Maybe it's going to be predictive quality, maybe it's going to be predictive maintenance, maybe with the higher bandwidths we're talking about, AR, VR are going to be things that are going to be of value. So to not answer too many questions you may ask here in the near future, but some of the things that are going to come out of this is the more data people can pull across these private networks, the more things they're going to find value into them. It's not going to be just one killer use case that makes 5G valuable. It's going to be hundreds of different things that you build on top of the network over time.
Right. Thanks, Rasmus. Any thoughts on the verticals?
No, I think we heard a lot of good comments already. A lot of use cases that will eventually motivate. I mean, it could be some killer use case initially, but it has to be a lot. No, I think on the verticals, I agree. Manufacturing, warehousing, and so forth is where you see a lot of interest and a lot of opportunity initially, and it's more like machines and things like that. And that's maybe ties into what I discussed before, that eventually we would like to see this also going to enterprises in general. But then you need something that's really differentiated from Wi-Fi. I mean, for manufacturing, warehouse, and so forth, high reliability, sub-6 works fine. You can replace cables with wireless connectivity. But we're going into enterprises and use cases, then you have Wi-Fi too, and Wi-Fi is not going to be replaced by 5G private networks. It's going to complement. But if you want something that's really differentiated, that's why we would like to see millimeter wave getting into these kind of use cases eventually. It's not going to be the first phase, but later on, and get this extreme capacity for maybe AR use cases and so forth, or feeding cameras for edge processing for AI and so forth.
So Vikas, it sounds like we're on the right path here, but what do we need to do to accelerate our path, our progress along the path? How do we get to 5G private networks as soon as possible?
Yeah, I think that's a very good question. And within the small cell forum also, we discuss about this, and we started an activity to build a blueprint. So blueprint is something that when we go to build a house, we make a blueprint. And if the house is successful at one place, we try to replicate at other places. So we thought about it, and last year we started this activity, and we already have selected 4 different blueprints, which we see is the industrial traction is there towards it. It is based on the data which has been done inside the small cell forum and the associated companies with that. So we selected 4 blueprints at the moment for the enterprise in the standalone mode. Second one is the enterprise along with the MNO. And 2 more interesting blueprints is related to the CB2X and Industrial 4.0. So what we are doing here is trying to make a blueprint so that the solution can be made based on those blueprints, and those can be not only just made, they tested, evaluated, works in certain scenarios, and then if we know that, and also the operators, for them is big thing is that, okay, this is good, everything is good, 5G is good, private network is good, but have we seen that somewhere running? So if we have a blueprint activity, we consolidate the use cases and then see that, okay, this kind of blueprint is work in a certain setting, and then is easier for replicate in the other scenarios as well with the other operators as well. So this is the activity we started, the blueprints within the small cell forum, just to take care of this problem that okay, everything is great, but how do we build a solution, end-to-end solution from the small components out of it?
Understood. That's interesting. Adil, your thoughts on how we accelerate deployment? How do we get things ready for the kind of scale that we're looking for?
Yeah, I think I would like to comment on one of the use cases that, and in connection to the previous question that we are discussing, right? One of the key use cases that we are also observing is the need to process as much data on the edge as possible. You may not want to basically take all the data to the cloud for a plethora of reasons. Could be you do not have a very big pipe despite 5G bandwidth, or you may not for security reasons, for example. So edge processing is becoming something that, and then we get requests a lot. I just wanted to add this to the previous discussion. Now, how to expedite 5G deployment, right? One of the things that we are observing, what is kind of slowing 5G deployment, is actually the cost of the overall solution. We hear things like, well, 5G is good, it has better capacity, better security, reliability, all the good things, but do I want to pay 10x for 5G as compared to what I'm paying for LTE right now, right? Eventually it comes to brass tacks of an IT manager on a factory floor. What is her budget, right? Can she justify a 10x or 20x investment in 5G? It's very important for 5G to come near the cost point of where LTE is, or where even enterprise 5G is, right? That is something that we see a big problem that need to be solved among all of us. Another challenge that we see for rapid 5G deployment that we are trying to solve is there are a bunch of components, in a sense, which need to be integrated. There's a bag of parts, right? There's always RF and RF front end and network processing and CPU and physical layer and 5G physical and 4G physical. Who puts all of them together? I think one of the things that we are discussing is what's the role of system integrators into that as well, right? So if a silicon company offers for higher level of integration, it makes the job of an ODM and OEM partner much better and easier, which in turn expedites the deployment of 5G.
Thanks, Adil. Rasmus, how do we get to 5G at scale as quickly as possible from your guys' perspective?
Yeah, so I think this comment about blueprints or having something set up like a template is very important. So, and that's something we believe in from our side, and we actually have gotten to action to start to do that. So we set up our lab, Qualcomm. We bring in our FSM small cell partners that use FSM is our chipset for small cell. We bring in that solution together with core network and other solutions, and we pre-integrated, what we call it, to make sure everything works, so it's ready to go for vertical specific use cases later on for system integrators to take and run with it. So yeah, I think that part is important, not only to define what such a blueprint should be, but also then start to test and verify, because you will find a lot more things that you didn't expect when you start to actually put things together. So I think that's a very important part. Then it's also about streamline and simplify the process to the plan and deploy and so forth. And there's going to be a lot of people that don't have the 5G expertise like an MNO has to put the solutions together. So people in industry want to have the lowest cost, the end customers, but they don't have the capability like a mobile operator to put the solution together. So we need some multi-vendor choice, but simplify that choice without forcing the end customer to actually put that together. So that's, I think that's two important parts.
Yeah, gotcha. TJ, how about from you?
Yeah, I agree. Simplification is going to be key. Absolutely. Listening to some big customers here in the last week, the large scale Fortune 100 companies, they've kind of brought everybody's product set, express probably everybody here, they have everybody's product in their labs. They've got the skill, they've got the ability to play with it and test it and trial it. But then there's a huge segment of customers out there that are hearing about private 5G and even private 4G. They're like, that need that system integrator that can just bring the solution to them and get them stood up and get them running. And one of the things too that I think we have to help demystify the market a little bit about is, for us in years of telecom, we know that working with MNOs, when you put something inside from a 3G, 4G, 5G perspective, you're covering everything from wall to wall, ceiling to floor. And with private networks, you don't have to have that kind of deployment scale anymore. You can start small and then help them grow. Which is really why like hyperscalers are such a great partner to come into private networks, because they've got the compute resources that allow you to start small and scale up that compute along the way. So I think a lot of great education into the market, working with key partners, and then I'll leave you with this one. It's going to come down to end devices. Getting end devices that are going to be cost effective and getting them in the hands of the customer is going to be essential to help scale.
Got it. So San, change up a little bit here. You know, we've heard a few folks mention Wi-Fi and, you know, private networks and Wi-Fi, and occasionally I get the sense that there is this either or mentality, and I don't see it that way, but I'm curious your perspective. How does Wi-Fi fit into this picture of a private network deployment?
Yeah, that's a very good question. I think actually there is a notion in the industry that, like, these private networks, are competing with Wi-Fi. It is true in certain sense, but they are complementing each other, like, in other, like, cases. It depends on the use case, right? There are use cases where you need, like, more stringent security. For example, like, certain, like, use cases in, like, robotics, factory automation, etc. You need lower latency. You need, more reliable, like, communication and so forth. Well, in these cases, it's obvious that, cellular has advantage. Cellular-based technology, which is like, the private networks, they have advantage over Wi-Fi. But there are use cases where, like, you don't have, like, very stringent, like, latency requirement or, like, reliability requirement, and etc. And Wi-Fi can play a role. That, in many enterprise, premises, Wi-Fi is already available, right? And so, going back to your previous question, that, how we can actually accelerate the deployment of private 5G networks, it just takes actually, obviously, to show, it all boils down to total cost of ownership. What it takes actually, for an enterprise or, like, a factory owner or, like, utility service or whatever, to deploy a private network. And this is actually, again, another area that I think the use of this network as a service, the availability of public and private clouds actually for deploying, part of this, disaggregated and virtualized, system would help to reduce that total cost of ownership. But again, Wi-Fi, yes, this is actually, in some cases and some use cases, is competing with Wi-Fi. In some use cases, Wi-Fi cannot address, like, when you have, like, as I said, very stringent, like, requirements that Wi-Fi cannot fulfill, QoS requirements, etc. But there are cases where Wi-Fi actually can do a good job, and Wi-Fi is already available, and, this can be, complemented to that.
Good, thanks, Hassan. So, time flies. It seems that we're already coming up on our half an hour that we were allocated. What I would like to do is go around to each of our panelists and ask one of my favorite types of questions, which is for you guys to pick up your crystal balls. Looking, 1 year, let's pick 2 points, 1 year and 5 years down the road. So Adil, 1 year and 5 years down the road, what do we expect out of the private network 5G world?
So, good question. I was thinking about this Wi-Fi and 5G and how they will coexist, and this will determine actually next 1 year and 5 years. So, one of my customers told me something very simple and sweet, and she said, on a factory floor or on a manufacturing floor, a human will always use Wi-Fi because it's just simple and it works, because she will always have a tablet or a phone which will be connected to a Wi-Fi access point, and a robot will always use 5G because a robot will need higher security and higher data and lower latency and higher reliability, right? So I think in next 1 to 5 years, what we are going to see is, from a 5G perspective, I see higher adoption of 5G, because I think the cost points are going to come down as the deployments scale. So in next 1 year, I think we'll see much more deployments of 5G than there are today. We'll see reforming of 4G to 5G, which means a lot of 4G bands will be reformed to 5G, which will need to be addressed. I also see that Wi-Fi, as Wi-Fi goes for higher bandwidth, for example, 8.11be is 320 megahertz, right? 4K QAM, very, very fat pipe. 5G will have to have some distinct feature set and capabilities and offerings, which is in parity with Wi-Fi, such that the lower latency, high reliability, higher security features of 5G can be deployed and will be deployed in a cost-effective manner.
Very good. Thanks, Adil. Vikas, how about you? 1 year and 5 year, what does your crystal ball tell us?
I think in the near terms, the 5G is going to be just in the initial phases. It's maybe some small setup we will see the 5G running. But I think there is a very interesting things which is coming up is CB2X, and which I see a lot of potentials with the 5G and the edge, and that is still untapped. So more and more connected vehicles you will see on the road, providing all kind of security and entertainment and other services. So I see in the long term, this use case is going to be prominent, and 5G and private network, and also the hosted RAN where the multiple PLMNs are there on the same network, is going to play a very important role.
Thanks, Vikas. Rasmus, how about you? What do your tarot cards tell you about the future?
Oh, for 1 year, I like Adil's comment about the factory floor, because I agree with that. That is really 1 year, we're going to probably see a little bit more robots and other things in warehouses and factories being connected to 5G. Separation of IT and OT systems. So you maybe have your Wi-Fi system and you let other things that's not critical for the production on. But eventually in 5 years, expect to see private network also for more end user humans to use, and maybe also with more types of devices with XR. XR is our internal name. I should call it AR, augmented reality, and VR and so forth. When you have also access to millimeter wave, but I think the initial 1 year perspective, more sub-6 machines, robots, and so forth. But we will get there to get private networks more used for humans too.
Thanks, Rasmus. Sasan, how about you and your predictions for the future?
Yeah, so I'm very convinced that, the necessity of, these private networks in, as I said, these, verticals, factory automation, port automation, surveillance, all those things is very clear. But, obviously there are some economical and, things, issues that, need to be resolved. The total cost of ownership is a very important factor. And I think actually in the near term, given right now with, some world situation, wars, etc., it's very hard to imagine, very big investments actually, in this area in the very, very near term, 1 year. But, I'm very optimistic that within 4 or 5 years from now, we will see a lot of these things, materialize in terms of factories, gets automated, using, these private networks. Utilities, can benefit. In fact, I'm living in California. I see that, we have lots of fires just because of some utility equipment actually goes, wrong or, is broken, causes fire and etc. Well, most of these things can be prevented by robotic, surveillance and having, continuous, observation and surveillance. And this is, one of the application areas of the private, 5G networks, that they can provide. So you see that, it's everyone is clear about the benefits. But there are more, some financial and economical things that, probably, impedes or, prolongs the deployment. But I'm very confident that, this will happen.
Excellent. Thanks, Hassan. TJ, you led us off today, and you get to close us with your predictions.
Excellent, excellent. So I'll lead it off, or I'll finish it off with one word. I think the difference between 1 and 5 years is the word hope. And I think we're going to see a lot of POCs, and I'll look at it from a business perspective. We're going to see a lot of POCs in the next year. But I think in 5 years, what we're going to see is we're going to see that that return on investment is actually there. The developer ecosystem is going to grow, application ecosystem is going to grow, the end device ecosystem is going to grow. And these early customers that are putting in private 5G networks now are going to stack on all those value-added solutions inside their facilities, and they're going to see that they have greater process efficiency, or that they have better overall ability to leverage the technology to make their business operate at a more cost-effective way. So I think we all have hope that this private 5G network market is going to be exciting in 5 years from now. But it's going to take all of us here working together to continue to bring great solutions to our customers.
Great concluding statement there. You couldn't have, you took my words and perfectly. So like to thank the esteemed panel here. It was an excellent discussion. I had lots more questions. I think we could probably keep going for an hour or more, but folks, unfortunately, our time is limited. With that, we'll go ahead and close the panel, and thank you all. Have a good day.
Thank you.
Thanks for having us. Bye-bye.